Okay, so today we're going to be talking about properties of exponents. This is another video on the quotient rule, also known as division. I just want to start off by reminding you the definition of exponents. Here I've got x to the third power. You just need to remember what that 3 means. That 3 means that we're going to write this x 3 times. 1, 2, and 3 times. So as long as you know that, we can actually figure out a quotient. And so let's go ahead and take a look at what one of those will look like. Okay, so I've got a problem here. My first example here is going to be x to the fifth, all divided by x to the third. And so if we simply use the definition of exponents to expand this out, in the numerator here, you will notice x to the fifth is going to be written with 5x's. So I'm going to go ahead and write this out. 1, 2, 3, 4, 5x's. I'm going to go ahead and extend this line, my fraction bar, a little bit longer. When I take a look in the denominator here, I have x to the third. I'm going to go ahead and write that as 1, 2, 3x's. You will notice here that I actually have some things that can actually cancel out. I have x divided by x. That can cancel. I have x divided by x, and I have x divided by x. You will notice that there are 3 sets of x's that will cancel. X divided by x is 1, and therefore, if I simplify this, if I take a look here, what's left over, there are simply 2 x's left over. This is going to be x to the second power. As soon as we finish this problem, if you take a look at this, we may ask ourselves, was there a way that we can take a shortcut instead of actually expanding x to the fifth power in the numerator and x to the third power in the denominator? Is there a shortcut we can take? And the answer is yes. This is where the quotient rule comes into play. So what we can actually do is, if you'll notice here, is that we can take the numerator, x to the fifth, and we can actually just simply subtract x to the third. And so this can be written in a general form. If, for example, if I have x to the a, and I divide that all by x to the b, then what we can do is we can just simply write this as x to the a minus b. And I can just simply subtract these, a minus b. I can go ahead and put a box around this here, and this is my general form. I am now going to go off and do a few more examples, but in general, this is all you need to actually do a quotient rule. I'm going to go ahead and do a few examples to show you kind of what things can look like. Okay, so the second scenario here you'll notice I've got a quotient as well, but in this time, the denominator actually has more y values. The exponent is larger. I've got y to the second, all divided by y to the fifth. And the quotient rule tells me that I can simply just take this and go ahead and subtract these. Once again, this is going to be 2 minus 5, and I'm going to go this direction. It must be the numerator minus the denominator's exponent. So I'm going to go ahead and put 2 minus 5. Now you'll notice here in this scenario that this is going to give me y to the negative 3 is what's going to happen. We're going to have a negative exponent. If you remember negative exponents, you just need to know that this can also be written if you wanted to write it without negative exponents, that we're going to take that y to the negative 3. That negative sign actually means the reciprocal, and so I'm going to go ahead and flip this back over, y to the 3 down in the denominator, and you're going to have 1 all over y to the third power as your answer. If you also want to think about this another way, the quotient rule is subtraction, yes, but if you simply just wanted to go from here directly to your answer, another way that I like to think of it is kind of the way I teach integers, and thinking about it as these guys going to war. If I think about it in the numerator, there are 2 y's in the numerator, and there are 5 y's in the denominator. And so when you start canceling these, you're clearly going to end up with 3 y's in the denominator. So as you cancel these off, because 5 is 3 bigger than 2. So anyway, a couple different ways to look at this, but yes, you can do just straight subtraction as well. Okay, so this last example that I'm going to be doing in this video is actually a fairly large exponents problem in which we actually have 3 things going on here. So we're going to go ahead and use this quotient rule to be able to handle basically 3 different situations in which we're going to end up with a solution here. So I tell my students, I say, if you have something with a fraction bar in it, you're always safe to go ahead and start yourself with a fraction. So I'm going to go ahead and give myself a fraction. I'm not quite sure what I'm going to need here. The very first scenario here is if I take a look at the coefficients in front of this, this is just 15 divided by 3. And so if I take 15 divided by 3, that's going to go ahead and give me a 5. And that 5 is going to be in the numerator. The reason why it's in the numerator is because the 15 is in the numerator. And so if this was the inverse, if this was the reciprocal of this, in which the 15 is in the denominator, then the 5 would be in the denominator. But in this scenario here, I've got 15 in the numerator, so 15 divided by 3 is 5. The second scenario I want to look at are my a's here. And so the a's, you'll notice here that there are 8 in the numerator and there are 5 in the denominator. And if I visualize this, they're going to start canceling each other off. There are going to be 3 a's left over. What I can recognize here is that those 3 a's are going to live in the numerator is what they are. So a to the third power is going to be in the numerator. The reason it's in the numerator is because there are more a's in the numerator, in other words, the 8. The next scenario that I have are the b's, and if I take a look at the b's here, I notice that there are 3 in the numerator and there are 7 in the denominator. And so when I go to subtract these, I'm actually going to end up with 4 b's, but I'm not going to end up with them in the numerator. They're going to actually end up in the denominator. So I'm going to have b to the 4th power down in the numerator. Okay, so the last thing that we have to deal with are our C's here on the end. And if you'll notice, take a look at this here, that there are actually 2 C's in the numerator and 2 C's in the denominator. And so if I subtract this, these guys are actually going to cancel each other out. And so we're not going to have any C's in our answer. Now, some of you guys might ask ourselves, C to the second minus C to the second is C to the 0. And we can talk about that in another video, what C to the 0 means. But at this scenario here, you can just think of these as canceling each other out. And so my final answer is going to be 5a to the 3rd, all divided by b to the 4th. I hope this helped you out on the quotient rule of exponents, and I hope you have a great day.